Hello, Math for Teachers 2. Welcome back. We're continuing with rational numbers and lesson number 12. Here we go. You want to make sure, again, to have paper and pencil or whatever writing utensil you choose. Think about your future students and what they would be possessing for a writing tool. Our lesson goals for lesson 12 is to become more familiar and be able to identify story problems using 3 different interpretations of multiplication. We're going to develop your ability to write story problems using the 3 different interpretations of multiplication and continue to deepen your understanding of how to represent multiplication story problems with appropriate number sentences and diagrams. So you can already see here how we're continuing to build our math vocabulary. So wherever you're doing that, whether it's in your head or on a piece of paper, make sure that you're making note of those things, because as future teachers, you will be explaining the terminologies as well as how to do the math. The same numeral with 2 meanings. Okay, so let's consider the following 2 number sentences. What is the difference between the numerals 3/4 in each of the equations? So the first equation is 3/4 plus 1.5. Okay, so I hit pause for a moment to cover up the second number sentence. This will allow your students to visually focus one at a time. So let's go back. We're going to consider 2 number sentences and think about the difference between the numerals 3/4 in each of the equations. The first equation is 3/4 plus 1.5. So 3/4 in this number sentence is a measurement, the quantity with respect to some basic measuring unit, BMU, basic measuring unit. Again, in this first number sentence, 3/4 plus 1.5, 3/4 represents the measurement, a quantity with respect to some BMU. Okay, so what I did was I used the drawing tool, and I just covered that up with a box, and you can see that I'm pulling it up and down. So you have that option, and you'll see this in example in further slides. So 3/4 times 1.5. 3/4 is the operator. It tells you what to do to 1.5. So 3/4 times 1.5. First one, 3/4 plus 1.5, measurement. 3/4 times 1.5, operator. And let's come back over. Again, help your students refocus. 3/4 plus 1.5. Measurement, and 3/4 here is the quantity with respect to some BMU. Second math sentence, 3/4 times 1.5. 3/4 then becomes the operator. It tells you what to do to 1.5. So the multiplication equations. For the following general multiplication equation, each letter represents measurements and which are operators. Okay, so A times B equals C. A tells you the number of groups. The operator tells you what to do to B. So A times B. B tells you the size of the group, the measurement, or a quantity with respect to some basic measuring unit, BMU. A operator times B measurement equals C. It tells you the size of the whole, Again, measurement, the quantity with respect to the same BMU as B. If you need to hit pause, you certainly can at any time during this video. Multiplication story problems. So we're going to continue our study of multiplication of rational numbers by thinking about how to write different types of story problems. Again, we're adding to our math vocabulary, and these story problems match particular multiplication number sentences. Okay, we're going to try to connect our work to, this will happen in the real world, your Math 172, which is your Math for Teachers 1, with the work that we do in this class and video. Okay, so multiplication story problems. Let's look at the different types. The first type is repeated addition. Now, this is something that we reviewed in lessons 9 and 10. Repeated additions. So here's an example. There are 3 packages of Twinkies. Each package contains 4 Twinkies. How many Twinkies will there be all together? Let's take a look. This is a combining of A groups of B objects. There is a for every or each or per idea embedded into the story. So let's come back up. You can see it's highlighted here, each. So these are your key words for repeated addition. You'll look for every, each, per within that sentence. Okay, let's look at the next one. The next one is rectangular array or area. Okay, so you'll be comfortable with this. We've done really well with area models. Okay, so now we're going to look at a multiplication problem. Lauren is making a batch of cookies. The cookie sheet fits 4 cookies across and 3 cookies down. How many cookies can Laura put on one cookie sheet? Okay, I'm going to suggest you take a deep breath, and this is when I'm going to remind you to put yourself in young children student mode with your brain. Right? The physical arrangement of A times B objects in a rectangular array with A rows and B columns. So on your piece of paper, you can hit pause, write down, illustrate that cookie sheet. 4 cookies across, 3 cookies down. How many cookies can Lauren put on one cookie sheet? Kind of reminds us of the story that we read in class when the doorbell rang. Right? So again, as you're thinking about these, you might make some connections to children's literature. And if you haven't already done that for one of your projects, there is 2 more projects. Next one is multiplicative comparison. Multiplicative is a word that you're going to want to rehearse saying. It is a mouthful. So here's the story problem. Ellie the elephant had 3 peanuts. His best friend Dumbo had 4 times as many. How many peanuts did Dumbo have? See, I tricked myself. Multiplicative comparison involves a multiplicative comparison between 2 quantities. A comparison. So there is times as many relationship between 2 amounts. Okay, again, you'll see keywords like times as many. Here it is, times as many. Okay, so there's some key words. Now, this is a lot of explanation in 4 really tight columns. So again, I'm going to suggest, is this the best way to introduce this to your students, or would you do 1 slide at a time? Is this a good reference sheet for your students, maybe during the first 2 weeks of explaining multiplication problem types, but then removing this reference as you advance in the concepts. Okay, one more. Cartesian product. This is a combination. So let's read this one. Emily has 3 hats and 4 pairs of sunglasses. How many different combinations of hats and sunglasses can she wear? Form all possible pairs of objects from 2 sets. The first set contains A elements, and the second set contains B elements. So again, I suggest that you hit pause, see if you can illustrate these different multiplication problems, and then you can restart the video. Okay, hoping that time was helpful to review the different types. This is where I will share with you the Cartesian product method does not make sense for fractions. So while it is a multiplication problem type, right, it's not one that we're going to use with fractions. Okay, so you can X that out. Good practice, good to understand that multiplication problem type, but not going to use it with fractions. Okay, let's go through the different problem types and see if you can differentiate. Here's the first one. A recipe for a batch of muffin calls for 1 1/4 cup of raisins. If Thomas wants to make 3 batches of muffins, how many cups of raisins does he need? If this sentence problem sounds familiar, you're referencing back to lessons 9 and 10. So again, a recipe for a batch of muffins calls for 1 1/4 cup of raisins. If Thomas wants to make 3 batches of muffins, how many cups of raisins does he need? Think about the different types of multiplication problems. Hit pause and see if you can figure this one out. It's a repeated addition. Okay, let's do the next one. Paul's wool scarf has 8/9 yards long. After he put it in the washing machine, it shrunk to 1/4 its original size. How long is Paul's wool scarf now? What type of multiplication problem is this? It's a multiplicative comparison. Find the vocabulary that dictates that, and you can reference back in the video or on the reference slides. Kayla buys a piece of property that is 1.5 miles long by 1 2/3 miles wide. How many square miles of property did Kayla buy? I'm just realizing I think I was showing you the answer while I was holding the cursor down. That's the rectangular area. Right? Okay. Jin Young has 5 6 of ribbon. Shikaku has 2 1/5 times as much ribbon. How much ribbon does Shikaku have? Multiplicative comparison. Again, encourage you to go back, look at this slide, think about the definition that's in green, and then revisit this slide. Okay. Last one. Joe likes to run a small distances for exercise. Usually she runs 7/5 of a mile every day. On the day after Thanksgiving, she was tired and only ran 1/4 of a day's worth. How far did she run after Thanksgiving? And this one is repeated addition. Okay, so I'm going to stop this lesson 12 part 1, but this will be posted and then there'll be a part 2.